Hello, students. Have you ever wondered why things rust or why your body produces energy in cells? It's all about redox reactions. The term oxidation originally meant adding oxygen to a substance. But here's the twist, it also now refers to the removal of hydrogen or the loss of electrons. On the flip side, reduction is essentially the reverse, the removal of oxygen, the addition of hydrogen, or gaining electrons. You might notice that oxidation and reduction always occur together. That's why they are called redox reactions. Think of them like a dance, one partner loses electrons, oxidation, while the other gains them, reduction. Both need each other. Now, let's look at oxidation in action. Picture this, when copper is exposed to oxygen, it forms a black oxide. This is a classic example of oxidation. You could say, copper plus oxygen gives copper oxide. The reaction goes to copper atoms react with one molecule of oxygen to form two copper oxide molecules. The oxygen is the oxidizing agent and copper acts as the reducing agent, losing electrons. A fun fact: the reddish-brown copper turns black as the oxide forms. That's the telltale sign of oxidation at work. So, you see, oxidation doesn't just happen in the lab, it's all around us. Let's dive a bit deeper. What if hydrogen gets removed from a substance? Here's an example. Hydrogen sulfide reacts with chlorine to form hydrochloric acid and sulfur. You could say, hydrogen sulfide plus chlorine gives hydrochloric acid and sulfur. The reaction looks like this. Hs plus Cl gives to H close plus S. Notice that chlorine takes away the hydrogen atoms from hydrogen sulfide, and that's what makes it oxidized. So, chlorine is the oxidizing agent and hydrogen sulfide is the reducing agent. This highlights that oxidation can also be the removal of hydrogen. Ever wondered how an element can be oxidized without oxygen? Well, meet chlorine. When ferrous chloride reacts with chlorine gas, it forms ferric chloride. You could say ferrous chloride plus chlorine gives ferric chloride. The reaction goes 2FeCl plus Cl gives 2FeCl. Chlorine, being electronegative, steals electrons from Fe superscript 2 ions, turning them into Fe superscript 3. In this case, chlorine acts as the oxidizing agent and ferrous chloride as the reducing agent. The key takeaway here is that oxidation can occur with the addition of electronegative elements like chlorine. Here's a fun one. When potassium iodide reacts with hydrogen peroxide, potassium iodide is oxidized. You could say potassium iodide plus hydrogen peroxide gives potassium hydroxide and iodine. The reaction looks like 2K plus HO gives 2KOH plus I. What's happening is that potassium, the electropositive element, is lost and iodine is released. This is a classic example of oxidation by the removal of an electropositive element. The hydrogen peroxide is the oxidizing agent and potassium iodide is the reducing agent. The violet vapors of iodine are a great visual clue that oxidation has taken place. Now, let's get to the core of what oxidation really means, the loss of electrons. Consider iron. When iron loses electrons, it forms iron ions. You could say iron gives iron ions and 2 electrons. The reaction is written as Fe gives Fe superscript 2 plus 2A. As iron loses electrons, it's undergoing oxidation. So, the reducing agent here is iron, and the counterpart species gaining those electrons is being reduced. This is the modern definition of oxidation, the loss of electrons. If you're ever confused about whether something is oxidized, just remember, it's all about electron loss. Let's now take a closer look at a full redox reaction. Here's the reaction. Hydrogen sulfide plus sulfur dioxide gives water and sulfur. The reaction looks like 2H2S plus SO2 gives 2H2O plus 3S. Step 1. Assign oxidation states. We have hydrogen as plus 1, sulfur in hydrogen sulfide as 2, and sulfur in sulfur dioxide as plus 4. In the products, we see that sulfur in hydrogen sulfide goes from 2 to 0, it's oxidized, while sulfur in sulfur dioxide goes from plus 4 to 0, it's reduced. By analyzing these changes, we can identify that hydrogen sulfide is the reducing agent and sulfur dioxide is the oxidizing agent. This step by step method of assigning oxidation states is a powerful tool to figure out which substance is getting oxidized and which is getting reduced. This, my friends, is the magic of redox chemistry.